Okay, guys, today we're gonna this is all a very new and unusual thing, but we're gonna go through this as quickly as we can. And then remember that these are all videos, so you can watch them, slow them down, rewind, whatever it is you need to do. So I'm gonna go through quickly because I found that like when I made one earlier, it's just way too long. So the next section that we're gonna study, this is the last section that should be like the hardest material that we're doing, and then into chapter 9, it's gonna be easy peasy lemon squeezy. So in section 8.5, we're going to be solving trig equations. And for the most part, you're going to treat these a lot like the way you would solve other types of equations, algebraic equations. You're going to be solving some right now that are trig equations of a linear form. Okay, so really what that means is trig equations of a linear form. Remember that that means something like 2x minus 5 equals 7. And so you think about how you would solve an algebraic equation. You would add 5 to both sides, divide by 2. Essentially, you're just isolating the variable. So the first step that you're going to take is you're going to isolate the trig function on one side of the equation. And then you're going to determine the quadrants in which the terminal side lies. Like think about the unit circle. You may need to take a unit circle out. And then you're going to have to determine like which quadrant it lies in, and then you're going to give two different types of solutions. You're going to give general solutions, and then you're going to give solutions over the interval 0 to 2 pi. So just be careful about some of these things a little bit. So I'm going to show you the first example. The general solutions are a little bit more challenging to do, but we'll talk about it, and I'll do it graphically, and then you can think about it algebraically if you wish. Then we'll do specific solutions, okay? So the first equation is tangent theta plus the square root of 3, plus square root of 3 is equal to 0, so just isolate the trig function by subtracting square root of 3. Tangent theta is equal to negative square root of 3. Okay, so this is step 1 right here. And the next thing you're going to do is you're going to ask yourself, like, for step 2, you're going to say, in which quadrants? So I think you want to really ask yourself, like, where is tangent negative, right? That's part of it. And which angles, and that might be step 3, I'm not sure. Which angles have tangent value of negative square root of 3. Okay, so this is where you really want to get your unit circle out. Use it as much as you can. Certainly when you're doing your homework and stuff like that, you're going to use that as much as you can. So tangent is negative in quadrant 2 and also in quadrant 4, right? Okay, so which angles, this was, where is tangent negative? That's this piece. And then the second piece of that is in which angles have that tangent value of negative square root of 3. And for that answer, that's going to be in quadrant 2, that's going to be 2 pi over 3. And in quadrant 4, that's going to be 5 pi over 3. If you have your unit circle in front of you, you should be able to find that. Remember that tangent is y over x if you don't write down those tangent values. Hopefully you get to know them soon. Okay, so for general solutions, what I want you to think about is when you state general solutions, be very careful, because what you are trying to do is you are trying to describe it in the most concise way possible. That's the challenging part. So when you're solving these and you're looking at the program, it's going to give you lots of different options here. But what I want you to think about is this. Think about where 2 pi over 3 lies in quadrant 2. That's right here. And think about where 5 pi over 3 lies in quadrant 4. That's right here. Okay, and so then I want you to think about the fact that can you add a constant value to get from quadrant 2, to get from 2 pi over 3 to 5 pi over 3, and then back again, like over and over and over again. So to get from 2 pi over 3 to 5 pi over 3, you should just be able to notice that since they kind of lie like in a straight line, that you could just add pi. So the general solution is going to be theta equals 2 pi over 3 plus k pi. Okay, and I think it's going to ask you for some sort of thing like that. It might be pi k. Sorry, you might just have to type in pi k, because I think it's going to give you the k already in the box. And you'd be typing in this piece, 2 pi over 3, and this piece, pi. Okay, that's one type. I'm going to show you another example in a minute. And then for your specific solutions on the interval from 0 to 2 pi. Remember that that means inclusive of 0, but exclusive of 2 pi. That's going to be theta equals, we already found them right above in step 2, 2 pi over 3 and 5 pi over 3. And that's it. Okay, this problem was really basic. The next one is not quite so basic. So I'm going to pause and flip to the next page and then show you a different type of problem. Might still be linear. There's a few more that are linear. They're not all that bad, but some get a little complicated. So I'm going to pause it for 1 second. Okay, picking up on page 218, there's some other examples. You probably see 5 examples, and these are not exactly in order. So I think for you, this problem is, this particular problem number 6 is over here somewhere. I'm not going to do all of these examples, but I'm going to do what I possibly can do. Okay, so for the first one, it says 5 cosecant theta minus 3 equals 2. Again, we're going to try to isolate the trig function. So we're going to get 5 cosecant theta equals 5, and then cosecant theta is equal to 1. I just divided both sides by 5. And then I do want you to think about what this is related to. So cosecant theta is equal to, remember that, sorry, I'm going to rewrite that a little bit. I'm going to write that as, remember that sine theta is equal to 1 over cosecant theta. So I'm just going to put 1 over 1 so that we can say that sine theta is equal to 1. In essence, you're just taking the reciprocal. Take the reciprocal of this side and write it as the reciprocal function. That's really all you got to do for this one. Okay, so sine theta equals 1. Step 1, remember that step 1 should be this. Step 1 for this particular problem would be, think about where sine is positive. Well, we isolated, sorry. So step 1 was isolate. Step 1 was isolate. We did that. The trig function, step 2. Step 2, where is sine positive? Sine is positive in quadrant 1 and in quadrant 2. Okay, so step 3, what are those angles? In quadrant 1 and quadrant 2. So what, and in this case, it actually doesn't lie in a particular quadrant. Remember that this one is tricky because this one lies sine theta equals 1 on the positive y-axis. So that one really didn't help us a lot. This one didn't do us a lot of good right here. So your solution, your general solution, in a sense, is going to be like this. General solution is going to be like, what's the angle that lies on the positive y-axis that has a y-coordinate or a sine value of 1? The general solution is going to be theta equals, look at your unit circle and find where the y-coordinate is 1 on the positive y-axis. That's pi over 2. Is the y-coordinate 1 any place else on your unit circle? Not anywhere else. So if you were like trying to understand where are all of the angles that are coterminal with pi over 2, that's only going to be at pi over 2. So the only thing that you can do is you can add 2 pi to get back to that. So this is going to be plus 2 pi k. And when you type it in MyMathLab, it's going to look something like that. And then the specific solution is only going to be that particular angle. Okay, it's not going to be anything else. You don't have multiple angles, so theta equals pi over 2. There are a lot of problems that are more challenging. This next one is kind of a lot more challenging for sure. We have the square root of 2 sine 2 theta plus 1 equals 0. Be careful because that 2 in between the trig function for sine and the theta, you can't just get rid of that. So there's kind of a tricky thing that you're going to have to do here. So remember that the first thing we're going to do is we're going to isolate, right? So to isolate, we're going to say sine 2 theta equals negative 1 over root 2, all right? And then I want you to think about where is sine negative, right? Sine is negative in quadrant 3 and quadrant 4. So for your general solutions, this is what's going to happen for your general solutions. And remember, be careful because we haven't solved for theta yet. So your general solutions are going to start off like this. You're going to start off with something like 2 theta is equal to, all right, and so we end up with, what are the angles in quadrant 3? That would be 5 pi over 4, right? And then also you have 2 theta equals, and in quadrant 4, it's going to be 7 pi over 4. So I left a lot of room because I still want you to think about what's going to happen and like what you're going to have to add. Is there a constant value? So 5 pi over 4 is here, 7 pi over 4 is here. Here's 5 pi over 4, and here's 7 pi over 4. Can you add a constant value to get from 5 pi over 4 to 7 pi over 4 and then back again? Notice that the gap is like a lot bigger, so you can't add like the set amount. Those kind of make a 90-degree angle. So you can't say I'm going to add pi over 2 one time and then I'm going to add 3 pi over 2 another time. So you have to include both of them, and then you're going to say for each one plus 2 pi k, and then it's going to be plus 2 pi k. Here's the trick, though. Now you've got to deal with this 2 theta. You can't have this 2 theta there. You're solving for theta, not for 2 theta. So now, to get rid of the 2, you can divide everything by 2, or you can multiply everything by 1/2. I'm going to multiply everything by 1/2 on both sides, here and here. Don't forget to do it here. Okay, and I'm also going to do it for the angle 7 pi over 4. And then also times 1/2. And then here's what your general solutions end up looking like. Theta equals 5 pi over 8 plus pi k. And you would type in the 5 pi over 8 and the pi. And then also theta equals 7 pi over 8 plus pi k when you cancel out the 2's. Okay? All right. So your general solutions look like this. Now your specific solutions now are going to get a little bit tricky in general, and it's not going to happen all the time. But usually when you see a multiplier in front of this, usually means you have that many, like twice as many solutions, means twice as many solutions. So if you had a 3 there, then you might have 3 times as many solutions on that interval 0 to 2 pi. So specific solution. So here's what we're going to do. We're going to say that our first specific solution is going to be 5 pi over 8. And then our next one is going to be 7 pi over 8. Okay? There's still a lot of wiggle room in between 0 and 2 pi because both of those values are both less than pi. So let's see if we're still less than 2 pi by adding pi to 5 pi over 8. So I want you to substitute, like think about substitute 1 for k in each of these expressions and see what you get. So if you do 5 pi over 8 plus pi, right? Remember pi would become 8 pi over 8, which would give you another solution here at 13 pi over 8. And then if you did the same thing for 7 pi over 8 plus pi, which remember was 8 pi over 8, then you would get 15 pi over 8. And how do you know that all of these are still less than 2 pi? Because remember, all of these less than 2 pi because 2 pi is equal to 16 pi over 8, right? Okay, so general solutions and specific solutions. Those are your specific solutions. You should write them in ascending order, like from least to greatest. They do like for you to do that. Sometimes the directions say that, sometimes they don't. This is getting kind of long, so I'm going to work this one last problem and then stop there maybe and cut it off, and then maybe pick up the other one in a few minutes. Pause the video for a little bit. You're not going to want to do all of this at once. I would probably suggest watch a few and then move on. So we're going to isolate first. Remember, 1 is isolate. So we're going to get cosine of theta minus pi over 3 equals 1. Step 2, where is cosine positive? And what angles have cosine value of 1? All right, so remember that cosine is positive in quadrant 1 and quadrant 4. Again, this one's tricky because cosine is positive on the positive x-axis. The cosine value is 1 on the positive axis. So this one lies at 0. Okay, so this one's going to be at 0. Remember that this is in radians. Okay, look at your unit circle. Remember to think about where is the x coordinate equal to 1, right? Because that was the cosine value we were looking for, cosine theta, okay? So here's what we've got at this point. Now your general solution is theta minus pi over 3 equals 0. All right, well, that's not really done because we got to isolate theta, so theta equals pi over 3. That's your general solution. If we only had, and remember we were going to have to say, okay, well, where else does the x-coordinate equal to 1? Nowhere else. It does not equal 1 anywhere besides on the positive x-axis. Remember, this was the ordered pair 1, 0. So this is at 0 radians. So this would be plus 2 pi k. All right, so it's going to be pi over 3 plus 2 pi k. That's your general solution, okay? And then your specific solution is going to be just pi over 3. Why is it only pi over 3? Well, if you add 2 pi to pi over 3, that takes you over the interval from 0 to 2 pi. Remember that you still have to be on the interval from 0 to 2 pi. So as soon as you go over that, it's kind of like going bust if you're playing blackjack or something like that. I know that there's a couple of other examples on that page, so I'm not gonna do those. I'm gonna skip to the next page. So I'm gonna pause it for a second and turn to page 219. Okay, on page 219, notice that this is a different objective. This is equations that are in a quadratic form. So remember, how would you solve something like x squared equals 27? Well, you'd probably take the square root of both sides, and you might forget to put the plus or minus in front. And then if you have a radical, obviously, if it's a perfect square, you take the square root or simplify the radical. So you got x equals plus or minus 3 root 3 right there. So we're going to do the same thing. We're still trying to isolate the trig function here. So I'm going to take the square root of both sides here, and I'm going to get tangent theta is equal to plus or minus, the square root of 1 is just 1. I know a lot of you forget to take the square root when you can, over the square root of 3. All right, and then we're going to do the same thing. We're still going to do general. We're going to do general formulas, and then we're also going to do specific solutions just on that interval. Okay, so we've got tangent theta is equal to plus or minus 1 over root 3. Let's take a look, just like graphically, visually on your circle, what that looks like. That's going to occur in 4 places because tangent is positive and negative in all 4 quadrants, right? So it's going to be at pi over 6, and at 5 pi over 6, and at 7 pi over 6, and also at 11 pi over 6. Remember that for general solutions, you are looking for the most concise way to say that. So I can't add the same amount to get from pi over 6 to 5 pi over 6 and so forth and so on, but you can add the certain amount just to get, remember that this is like 180 degrees, so you could say I can get from pi over 6 to 7 pi over 6. So for your general solutions, you could say that theta is equal to pi over 6 plus pi k, right? That's one solution. That's going to cover every angle forever and ever and ever, coterminal with pi over 6 and 7 pi over 6. And you could also say that it's 5 pi over 6 plus pi k. And you're going to have to, that'll be when it's asking you maybe like for 2 solutions. If you want to show me sometimes your screen and I'll take a look at it and show you what I'm talking about, we can try that. On the specific solutions, we really just already found them. So we already listed all of them out almost. It's easier oftentimes to find specific solutions first, but it can be challenging when there's a multiplier in front of theta. So pi over 6, and then 5 pi over 6, 7 pi over 6, and 11 pi over 6. This is the kind of section like on the exam when I was getting certified that I was angry about because I forgot a comma. If you forget a comma, it's going to subtract points because it's not seeing it as separate answers, okay? All right, there's another one down at the bottom of this page, 4 cosine to the 4th theta. So again, you're going to have to remember to think about this as quadratic. For some of you, you may want to try using U substitution, like we've done this before a little bit. Let U equal cosine squared theta. That would make this problem a little bit easier for you to solve because then you would get something like this. You would get 4u squared minus 7u plus 3 equals 0. And we can work this all the way through with u and then go back and put in the cosine squared at the end. So I know some of you are going to kind of forget that you can factor this. I don't think there's anywhere you'd have to use the quadratic formula in your homework, I need to get a 7 for the middle. So for the factors of 4, I'm going to use 4u and 1u. And then I'm going to use 3 and 1 because I know that 4 plus 3 is 7. So I'm going to put a negative in front of both of those because I need a 7u. So now I've got 4u minus 3 equals 0, u minus 1 equals 0. So we get u equals 3/4, and we get u equals 1. Now I'm going to go back in and put in the cosine squared theta like this. So cosine squared theta equals 3/4, and cosine squared theta equals 1. So here's what that's going to give me now. That's going to give me, if I take the square root of both sides, that's going to give me cosine theta is equal to square root of 3 over 2. Don't forget the plus or minus because that's what we're going to forget. And cosine theta is equal to plus or minus 1. So that's a lot of angles to consider. Let's take a look at square root of 3 over 2. That's going to be, remember that you've got 4 quadrants because it's positive and negative. So we've got pi over 6. We've also got 5 pi over 6, 7 pi over 6, and also 11 pi over 6. You can add a constant amount of pi to get from pi over 6 to 7 pi over 6 and back again, and then same thing for 5 pi over 6 to 11 pi over 6. For the general, and then same thing, let's look at a similar graph for cosine theta equals plus or minus 1. That's on the positive x-axis, but also on the negative x-axis at pi. Remember that ordered pair is -1, 0, and this ordered pair at 0 is the ordered pair 1, 0. Okay? So here are your general solutions. Your general solutions in shortest form possible are going to be theta equals pi over 6 plus pi k. And you're also going to have 5 pi over 6 plus pi k. You should also be able to type in, there's one more. You should also be able to type in 0 plus pi k. Remember that you have to do the least. So 0 is the least, not pi. We're going to start with 0 instead of pi. All right? And then for the specific solutions, you're going to have to list all these out. So theta is equal to, I'm going to try to go in order from least to greatest. So theta could be equal to 0 radians, pi over 6 radians, 5 pi over 6 radians, pi, 7 pi over 6, and then 11 pi over 6. All right. That's quadratic form. Okay. And then on page 220 is when you're going to have to deal with when you have equations in a different form. I'm going to pause it one more time to turn over to page. Okay, this is getting way too long. I know it is. So you just have to stop and go and do some and then stop and pick up where you left off. You need to get equations to all have the same trig function. One type of trig function. Figure out which one is easier. I don't know that cosine theta is equal to anything in terms of sine, but I do recall that sine squared theta plus cosine squared theta is equal to 1. So I'm going to replace this sine squared theta with 1 minus cosine squared theta. So my new equation looks like 3 cosine theta plus 3 equals 2 times 1 minus cosine squared theta. Distribute 3 cosine theta plus 3 equals 2 minus 2 cosine squared theta. Okay, again, this looks like quadratic, so let u equal cosine theta. Then if you replace that, you get 3u plus 3 equals 2 minus 2u squared. That's a little bit easier to solve. 2u squared plus 3u plus 1 equals 0 when you set it equals 0. Factor 2u, 1, 1, 0. Okay, and then you need both a plus and a plus. You're going to have to check your factoring. I know some of you have forgotten factoring, so go back, do a little review. If you need some help with that, then you can just let me know, or you can use quadratic formula and get it that way. So then I'm going to get u equals -1/2 or u equals -1. Go back and don't forget that this was equal to cosine theta. So cosine theta equals -1/2 or cosine theta equals -1. So remember, I want to know what angles have a cosine value of negative 1/2 and negative 1. That's really kind of what I'm trying to focus on a little bit right there. So cosine is negative in quadrant 3 and in quadrant 2. Sorry, I should have done that first. So it's going to be at 2 pi over 3 and also at 4 pi over 3. And it's going to be negative 1 on the negative x-axis at pi, right? Okay, so your general solutions, since you can't add a constant amount to get from 2 pi over 3 to 5 pi over 3 and to 4 pi over 3 and then back again, that's no good. You're going to have to include both of them. So it's going to be theta equals 2 pi over 3 plus 2 pi k, right? That's going to be one thing. And also 4 pi over 3 plus 2 pi k. I know I didn't go from least to greatest. That's okay. And then also it's going to be pi plus 2 pi k, right? Odd multiples of pi. So you do, in this case, need the pi. And then your specific solutions are the ones that we already found. Theta equals 2 pi over 3 pi and 4 pi over 3. And then you're done with that one. Just look out for when you have extra stuff. The main thing is you're going to have to figure out what you can substitute there a little bit. And then moving on to page 221, take a second, catch your breath. I'm going to move on to page 221 in 1 second. All right, on page 221, you can see how long this video is taken, so you know it would have taken exactly that. It would have taken at least twice as long in class as well, but at least you can stop, rewind, go back, or just listen to what you need to listen to at one time. So the problem right here is this cosine of 2 theta. Can't have that. So I'm going to try to get everything in terms of sine. You're going to have to go back and look at page 216 with all those double angle and half angle formulas, and you're going to have to recall that one of the formulas for cosine of 2 theta is that cosine of 2 theta is equal to 1 minus 2 sine squared theta. You had them all to look up, and yes, you would still continue to have them all to look up. That's not going to be a big deal. So I'm going to replace this with 1 minus 2 sine squared theta, and then don't forget your minus 3 equals negative 5 sine theta. This is of a quadratic form because it's sine squared, so I'm going to move everything to the right side of the equation so that the 2 sine squared theta will be positive. And again, you can let u equals sine theta, and then that'll make it a little bit easier. So if I did that, I would have 1 minus 2u squared minus 3 equals negative 5u. And of course, I'm going to combine the 1 and the negative 3 at the same time and then move everything over. So I'm going to get 0 equals 2u squared. 1 minus 3 is negative 2. But when I move it to the other side, it's going to be positive 2. And then don't forget the minus 5u. So I'm going to put everything in order. And again, try to factor. I need to get a 5. So somehow or another, I'm going to have to multiply this 2 that's in front by this other 2 back here so that I can get a 4 and a 1, right? And then it's going to be negative and negative because I need the last term to be positive and the middle term to be negative, okay? So now we've got u is equal to 1/2 or u equal 2. So now here's where we are when we plug in sine theta again. We've got sine theta equals 1/2 or sine theta, equals 2. Here's the good news. Good news is, remember that sine and cosine cannot be outside of the range from -1 to 1. If you try on your calculator to do inverse sine of 2, it's going to give you a domain error. So you can just kind of negate that solution altogether. And then you're going to say, where is sine positive and which angles, right? So if you look at it graphically, sine is positive 1/2 at pi over 6 and at 5 pi over 6. There's not a constant amount. Like this gap is smaller than this gap. This is what I mean by that. It's not just like the same amount over and over and over again. So since you can't do that, you're going to need both of those angles. Your general solutions are going to be theta equals pi over 6 plus 2 pi k, comma 5 pi over 6 plus 2 pi k. And you're going to have to type in those things, right? And then your specific solutions, sometimes it's only going to ask you for specific. So just be careful, don't do more work than you need to. If it only asks you for specific solutions, it's a lot easier. And that's going to be theta equals pi over 6 and comma 5 pi over 6. Okay, I don't think you're going to have to type in the theta at all. And then you're going to have to solve some using a calculator. These will be a little bit tricky because sometimes you will need the reference angles a little bit to figure that out. In general, you may want to make it so that your equation looks like a calculator-ready answer. Remember that if you're solving for theta, you're going to take the inverse sine of both sides. So that sine like to the -1 is what it looks like. And so now you have theta equals inverse sine of -0.2. So I am looking for answers. I'm looking for answers in quadrant 3 and in quadrant 4 where sine is negative. Need answers in quadrant 3 and quadrant 4. Here's the hard part. Remember, and in this case, we're only going to do on the interval. You're not going to have to do general solutions, not with your decimal and your calculator. The challenging part is that when you type this into your calculator, it's going to give you a negative angle that lies in quadrant 4. So please make sure that your calculator is in radian mode, and mine's not, so I got to convert it. And then you're going to press second sine of -0.2. And what I get is I get this angle that lies in quadrant 4 that goes this way. Remember, it's giving me a negative angle, so it's giving me -0.2014 if I'm rounding it to 4 decimal places, but I need it to be on that interval 0 to 2 pi. So here's something that I definitely need to know. I kind of need to know what's the reference angle. So the reference angle is equal to, it's the same angle as this, but it would be in quadrant 1. That the tricky part will be finding the reference angle sometimes. So this is just going to be 0.201, excuse me, 0.22014. That's an approximation, okay? And in order for me to figure out what these other angles are, there's a couple of things that I can do. If I've already got the negative angle in quadrant 4, right, and it's a negative angle, then I could just add 2 pi to this, and then that's going to give me the quadrant 4 angle. So if I do plus 2 pi, that's going to give me the angle 6.0818. Right? But the quadrant 3 angle doesn't come from that, okay? So be careful a little bit. I'm going to back up, and I'm going to do second sine, again, -0.2. And then I want to get the reference angle. To get the reference angle, I'm just going to multiply this by -1 to flip it up into quadrant 1. And then if I'm at the reference angle and want to get the quadrant 3 angle, I have to add pi to that, okay? So this is going to be a little bit tricky, so then I'm going to do plus pi. And then you're going to get 3.3430. And those are your two angles in quadrant 3 and in quadrant 4. These will probably be the trickiest ones that you could possibly do. And when you're checking your answers on MyMathLab, sometimes it'll say that plus or minus amount. That's giving you a margin of error, so be careful a little bit. You always want to think about where they should lie, and then a good point of reference, if you can figure out which quadrant they lie in, remember that this is 0 and this is approximately 3.14. So this would be about 1.57, excuse me, it doesn't look like a 5, 1.57. And then this would be about 4.71, I think, and then 6.28. So you can find out if you're even close by approximating and seeing if they're within that range. What I mean by that is I know I have a quadrant 3 angle when I see 3.3430 because it's between 3.14 and 4.71. Okay, I would try the others on your own a little bit. This is what you need. Quadrant 1 and quadrant 4 angles. Your calculator will give you this one. Your calculator gives the quadrant 1 angle because inverse cosine is only from 0 to pi. That's kind of why it's only giving you that angle. So when I do second cosine of 0.01, it's going to give me theta is approximately 1.5608. So that's in quadrant 1. To get the angle that's in quadrant 4, if I'm already at an angle that's in quadrant 1, right, then what I can do is I can say For the quadrant 4 angle, I'm going to have to do 2 pi minus the reference angle, but this is its own reference angle, so I'm just going to do 2 pi minus answer, 2 pi minus the 1.5608, so I'm just going to do 2 pi minus the answer, and I'm going to get the other possible value in quadrant 4 is 4.7224. Okay? Tangent. When you do inverse tangent, remember that inverse tangent only exists in quadrants 1 and 4, right? So your calculator will provide, because it's positive, your calculator will give a quadrant 1 answer. And so find the quadrant 3 answer, which is where tangent is also positive, by adding pi to the first answer. Okay, so you're going to do inverse tangent of 0.62. Theta is equal to that. So then you're going to get theta is approximately second tangent 0.62. And you're going to get 0.55, yikes, 50. And then you're going to add pi to that plus pi to get your quadrant 3 answer, or 3.6966. Okay, so 0.5550 and 3.6966. Those should be the two answers. I know this was really long. Hopefully you would stop. I don't expect anything else from here on out to be this long.